Welcome back, everyone. We are ready to kickstart the second half of our Developer Day, and our next speaker is Ted Hellman. He will be giving his TED Talk on extending the Splunk platform. Over to you, Ted.
Hello, hope everyone's having a good day so far. Thanks for joining for my talk on extending the Splunk platform. Um, you may be disappointed by this, but I am not going to talk about AI during this section. I'm going to talk about the Splunk app platform and the fundamental ways that you can actually add functionality to it through apps. So hopefully that is intriguing and you'll learn a bunch more in this session. Note that I'm going to sort of lightly keep an eye on the comments over to the side here. So if you have something you want to ask me about, go ahead and do it. I will probably not notice for 5 minutes, and then we can talk about it as soon as I do. So who's this guy? Um, Hi. My 10-year anniversary at Splunk was this Saturday. So I've been around for a little bit, and I'm very excited to share some of what I've learned during this time. I've bounced all over the place at Splunk with a whole bunch of different responsibilities over the years, but the theme has typically been around our application platform and what we can do to empower developers to build really great apps on top of the Splunk platform to help our mutual customers. So, as part of this, I'm currently a PM in our app runtime area as well as in platform security. So, you'll see me commenting on all of those topics, but you probably know me from somewhere like Cloud Vetting or App Inspect or Splunk Base in the past. I can still help out with those topics. If you have any sort of questions on those, you can always hit me up on the Splunk user groups Slack workspace, where you can just at Ted and get directly at me. Um, Very proud of all that, but I'm also very proud of this T-shirt. So I had two goals when I joined Splunk: get a Splunk T-shirt, slogan approved, and then become inducted into the Splunk Trust class, the Splunk Trust group. I was inducted as class of 23, and the dark mode T-shirt is one that I got approved in 2018. So I was very happy to get all of these things accomplished. And note that I listed those on the slide above my PhD, which is in test-driven development of user interface-based systems. Um, I bring that kind of validation and test-focused approach to everything I do at Splunk. So I think you might get a little bit of that during this talk today. So that's who I am. What am I here to talk about? So people have been talking about apps and providing kind of different definitions of what a Splunk app means to them. And some of this is vibes based, like it depends on what you're trying to do when you're talking about what you consider an app to be. So my definition is a packaged business outcome. So you're trying to do something that has like business value to someone. You're trying to unlock data so that people can use it to solve a problem. You're trying to streamline a workflow. Like that's a business outcome. And so the Splunk app is just your delivery mechanism for getting that business outcome into your customers' hands, right? So there's three main things that I consider part of this business outcome. The first is configurations. So your app may include a package of configurations for Splunk as a whole, like different users, roles, stuff like that, that you've packaged up and you're trying to get on a specific system. Or it may include configuration for your app itself. Like Add-on Builder has a really great example of this. You've got addonbuilder.conf. That's specific information that Splunk should know about your app when it's attempting to run it. Okay, great. Not really the focus of this talk. The second thing that's not a focus of this talk is content. So the really critical experience of Splunk is in terms of like the dashboards that you expose to your end users, and maybe lookups, stuff like that, that powers those dashboards alongside of configurations. Um, this has been really critical to the longevity of Splunk and the success of its app platform. And so I'm also not going to talk about that today. What I am going to talk about is platform extensions. So if you have some sort of code that you're attempting to deliver as part of your business outcome that is powering an experience in your app, that is a platform extension. And it hooks into the Splunk platform in a very structured way so that Splunk can recognize it, interpret it, and then use it to deliver that value. That's what I'm talking about today. So platform extensions as part of the Splunk app platform really kind of crystallized out of a bunch of predecessors around the Splunk 4, Splunk 4.3 timeframe, which is around when I was graduating undergrad. So it's been a while, right? But the formation of these different extension points really came together when Splunk Web Platform was integrated back into the Splunk core product, and everything started to come together as a business outcome package. Okay, well, so that actually phrasing probably raises another question: is like, what do we mean Splunk Platform? Well, the Splunk product is a set of several distinct platforms. And this is important for this talk because when I'm discussing an extension point, I mean an extension point to one of these platforms. And the platform that you're targeting has some implications on the way that your extension points are exposed, the way that users will experience them, and things around persistence of your code on the back end, stuff like that. So the three main platforms that make up Splunk are starting with Splunk Web, which, if you've been paying attention to the process names for the past 20 years, is just Splunk Web, lowercase. This is the platform that runs front end components to Splunk. Asterisk, it also runs back end components too. So typically, the ones you're probably familiar with are things like custom visualizations, which are just JS rendering of reusable like chart components in simple XML or in Splunk UI. But you can also use this to trigger functionality on the back end, which I'm going to touch on very briefly in a bit. So it's a complex platform, right? And you need to be aware of that going into potentially extending it. The Splunk core platform, which you know and love as Splunk D, that's when we're talking about core functionality of Splunk, like search, processing, alerting, stuff like that. This is what probably I want to say 90% of the extension platform is targeted on, is these backend features that support like Python execution, stuff like that. And then the platform that I don't think there's a lot of awareness at all is the Splunk CLI. So the Splunk CLI itself is not just for running Splunk Start or whatever. This is an extensible platform that you can use to add some really high value functionality to your apps. Each of those has a specific structure that it uses to expose functionality. When you're selecting like how to deliver this functionality through an app, you essentially pick one of these extension points and then use that to inject your functionality into the appropriate platform. Okay, platform extension. Like, what is the actual thing that I'm talking about? So here's an example to anchor this discussion. Um, This on the right is a mod alert. It's a modular alert specific type of extension that is composed of a couple of different things. So there is default configurations related to your extension point that are shipped in the default directory of your app. This is either expected to serve as a template for how your extension point works, or what information it will need to collect from users before it can actually function correctly, or just like I was saying, a template for instantiating a specific version of your extension point. Sometimes you see this go in the default directory. Sometimes you see it go in a conf.spec directory. Can everyone hear me? Somebody pinged me on the side.
Yep, we can hear you.
Nick, sorry, man. I don't know what to tell you. Oh, he couldn't hear me say that. Okay, well, someone told him in the chat that they could hear me. Yeah, I don't know what's been going on with that. Just let me know if something happens again. So, when your extension point is configured, when it's instantiated by an admin, that usually goes in a local directory. So sometimes this will be reflected in the exact same type of configuration file as you see the default configurations in, but I've specifically picked an example where it goes somewhere else. So when someone instantiates your modular alert, a specific example, that configuration goes in the local saved searches.conf. So it's a little bit tricky to understand like how your app can be deployed, but it is consistent once you learn the pattern for that extension point. So, and again, local configurations are expected to layer on top of default configurations to provide the effective configurations under which your app will run. Cool. Most of the scripts, well, actually, all of the scripts except one, all of the extension points I'm going to talk about except one today also have a script that powers them. This must go in the bin directory, at least the initial script handler that you specify in your extension point, and then you can call whatever more complicated code or libraries from that extension point that you need in order for Splunk to function. And asterisk, of course, I'll come back to a couple of differences with that in a minute. The way I've structured this also is talking about the different stages of kind of the Splunk lifecycle. And so we're going to start with ingest and then kind of move through a couple of different phases, talking about different extension points along the way. So we're going to start with one that people who've been working with Splunk for a while are deeply familiar with. And then I will throw you a curveball in like 2 minutes. So stay with me here if you're a more experienced developer. If this is your first time learning about Splunk app development, you're going to want to know about modular inputs. This is one of the workhorses of the extension platform, and it's essentially Splunk providing a way for you to do pull-based data collection of some type of data that Splunk doesn't handle out of the box, right? So we made the business decision very early on that we are not going to be able to cover every single type of data collection strategy or every data source. And so we put together a extension point to allow you to inject your own data collection capability for reaching out to external systems and pulling that data back in. The key thing here is that this is flexible configuration. So you're essentially saying, here is a modular input that allows you to connect to this specific data source or type of data, but a customer may have more than one data source to collect from. And so instead of making you like redefine different versions of these inputs, which we'll get to in a second, um, you have a configuration format that allows you to walk an admin through configuration of your input so that they can do it not only for their specific environment, but more than once for their environment. For example, I've worked in places where you have multiple Jira instances, and if you wanted to pull all of that data in on a schedule from all of those different instances, you would need multiple instantiations of your input to cover all of that collection. So, very, very common use case. 100% of customers are using modular inputs. So, the key components here, you have some sort of specification experience. In inputs.conf.spec that is used to build the Splunk web configuration screens for your input. So there's literally a UI that an admin experiences where they say, I would like to create a new input of this type. What information do I need to provide? This is the structured way of getting that information into the system. You also have an inputs.conf, which is a little bit more nuanced in modular inputs than in some other cases, but it's basically allowing you to store defaults for your modular input. And then you have a script handler that is just going to be matching the stanza name where your input is defined that implements a couple of key functions that Splunk expects to be there. Now, this is where I flip to the first slide showing actual hard content about what an extension looks like. And I'm expecting the developers who've been around for a while to beat me up in the comments. Definitely come at me. I would prefer you make sure everyone catches any mistakes I've made. So modular input. Oh, wait, there's one more. Cool. Pull-based data inputs. This means that the data is outside of any context that Splunk has, right? And so when you start a mod input up for the first time, it's going to go back some configured period to start data collection over again. What you do not want to happen is every time the modular input script gets restarted, that it starts from the beginning and you end up with duplicate data ingest. Um, the protocol gives you a checkpoint directory that you can use. It's a location that Splunk ensures is available on disk for your app to write to, for you to write, this is where I collected the last event. Please start from this timestamp next time. Cool. You can also use KV service. You can have a checkpoint file inside your own app directory, like whatever. The main point is you should do checkpointing. Otherwise, customers will always have to do some sort of deduplication when they're trying to use the event that you're ingesting. The other gotcha is around run only one. So a common deployment pattern sees inputs deployed on a search head cluster. And run only one is used to ensure that only one instance of your script is running at a specific point in time. So if your script parallelizes nicely, maybe you don't want to enforce this. If it does not, then you can use this to ensure that that's not running all on all search heads in your search head cluster. Cool. Okay, so those are the GOTS. The cool thing is modular inputs, because these are expected to be like high performance, high ingest sort of extension point have an architecture specific directory for your script handler. So if you want to compile a script so that it's really, really fast on 64-bit Windows or something like that, you can actually just drop that in to the Windows x86 64 bin directory in your app. And Splunk will know if that exists for the platform that it's running on to just run that version of your input script. So super cool. If it's a platform that Splunk doesn't recognize, it's always going to fall back to the bin directory. And so if you want to do some cool things with optimization, this is definitely a feature you should pay attention to. So what does it look like? This is just what I was talking about earlier. Your conf.spec has your essentially template for collecting the configuration information required for your input to function. You're going to have an default slash inputs.conf. It's a little bit niche, but if you want to use configurations that must apply to every version of your input unless they are overridden, this is where you would drop that information. I'm doing the python.required call out once in this presentation. I'm not going to mention it for every single extension point. But if your script is Python, you should have a python.required that targets the specific Python runtime your app is expecting to be run under. Cool. When your app is actually, sorry, when your input is actually instantiated, then that goes into that local directory I was talking about with a specific instance name. So this is how you can end up with more than one of those inputs collecting data at the same time with the specific parameters that the admin configured it to actually use. So API key to use is actually going to be a hard API key once this is correctly configured. So at a high level, this is what you end up looking at, looking like in your actual implementation. Just a couple of methods that you need to implement. The get scheme method is the one that's actually doing like handing Splunk back. This is the scheme I'm expecting. Validate input is used for you to actually say like, hey, this is not an API key or whatever. And then stream events is where you actually do the meat of this. I believe it's not Python 1.3, it's just 3. Did I say Python 1.3? I would double check that. Python.required equals 3. Yeah, that might be right. Nick might be right in the chat here. I will need to double check that after the presentation, but it might be Python.required is just 3.9. I might be confusing the old Python version with Python.required. Okay, good. Nick gets the first blood. So scripted inputs, moving on to the next one, is a little bit different. So I mentioned modular inputs are modular, and there's another input type that's not. So scripted inputs, essentially just hard-coded configurations. Splunk will run precisely one of these. If you wanted to run two different processes based on the same script, you actually would have to duplicate define that or whatever. And the key thing here is if you want to configure a scripted input, you have to do that through like a text editor or whatever on the actual file system. So Splunk Cloud customers cannot use scripted inputs if there's any configuration required. So, I mean, they're good if you want to do pull-based ingest and you know in advance every single thing you're going to need to access the data source. So if it's a public data source that isn't authenticated or whatever, yeah, maybe that's an option for you. Or 99% of what I see people use this for is just kicking a script off on a schedule and keeping it alive. So keeping it alive. The interval parameter, which you may see with mod inputs and is like 60 seconds by default, has some special values that really matter for scripted inputs that are not exactly doing inputs, but are just scripted like whatevers. So you have two values you can use for this, either -1, which is run this input once when Splunk starts, and 0, which is no, seriously, anytime this script exits, restart it. Okay, let's break that down a little bit. You might have an interval of 0 if you're using this to kick off some sort of script that ensures a service is running that your app will not function without. So anytime that service is terminated, restart it so that your app can continue functioning. Cool. -1 is also really, really important. So if your app has any sort of migration functionality or first time run functionality, like I need to ensure that like a parameter is converted into a different type because I've updated my app to a new version and I need to map between the different configuration types, or every time Splunk runs, I want it to contact my license server and make sure that the user is still has a valid license entitlement. Those are the sort of things you might want to use a -1 interval for with your scripted input. So this is a super heavy hitter in terms of like value to developers who are trying to deliver business outcomes to customers as part of a business that they're running. Um, but the input part is maybe not the focus of exactly what's going on here. Let's take a look at this. So it's abbreviated, right? There's not as much configuration here, and the configuration is kind of an older style than modular inputs. So notice the type of input is just script. So in modular inputs before, you were defining a type of input. The input type here is script. And what you're passing it as an argument is the actual location of the script that you want to invoke, which Splunk will just run. So notice you can actually pass optional configuration arguments in there, as well as any other configurations that you want to pass into that script that are hard coded, right? So if you had a hard coded API key for some reason, please don't do this. You would just include that in the inputs.conf stanza defining your scripted input. Cool. So people are probably familiar with those if they've been around Splunk for a while. And show of hands in the chat, does anyone know what I'm talking about with unarchived scripts? I actually have a side bet going on whether people have heard about this before. So far, so good. All right. Well, if this is new to everyone, let me continue. Unarchived scripts are really neat. This is a niche kind of use case in Splunk that is very deeply valuable to me personally, and so I'm very excited to share this with you. So this is for pre-index time data manipulation. So it's between when some sort of service results in data being sent to an indexer, and that indexer actually indexing that event. Now you may be asking yourself, why would I do this when ingest processor and edge processor exist? Well, yes, please use those. However, I want you to know about this extension point anyway. Cool. So if you are trying to do some sort of proprietary data format that needs a proprietary type of data archiving function in order to actually be ingested into Splunk, this is where you would inject that as a custom archive script. So it allows you to shell out to your unarchiving tool of choice and then continue with processing that data on your indexer. But because of what I just said, you should be thinking like, I think I can also use this just to do something on this data before it gets indexed, right? And that is correct. So here's how it works. You have a props.conf defining a source, which is indicating like, hey, this unarchived script operates on this source of data. And then you specify invalid cause equals archive. This is literally the flag that selects the extension point here, very unintuitively named, but when you select archive, that is how it knows to run your command. You have a source type that is specifying what source type will come out of this pipeline that you want Splunk to continue the ingest pipeline on. And then you specify your command, again, executed on the terminal. One quick note about this, that script must exit with 0 or Splunk will chuck a whole bunch of wobblies around assuming that your ingest actually failed with this data type. So the script needs to return 0. Let me give you a quick example of what this looks like. Very quick, right? Just a props.conf where you're specifying that script. So in the example I'm using, I'm pulling this from Tyler Muth's presentations in the past. You can just hit a command line tool that exists on the system where you're running your indexer in order to do this processing on these events. So, okay, why would you do that? Here is a very specific example that I hope will resonate. So here's a data type that I have to deal with all the time. This is the format of results that you get back from app inspect. Notice the way this JSON blob is structured. Now, if you're thinking like in terms of SPL, how would I write a query that would actually operate on this? Like if I have a check name that could be a failure or a future failure or a warning, this becomes very difficult to work with. You end up having to do like a multi-search and like parallel processing that search and then SPath a bunch to pull these events out. Or you can just flatten the data as it comes in. And then this is extremely easy to work with in SPL. Cool. So that's what that JQ command actually does as part of the unarchived script. It's just an example of, oops, sorry, I meant to go back one. Example of, hey, I would like to use this existing tool, which is more appropriate to the processing that I want to do, before the data makes its way into Splunk and becomes hard to work with, right? So unarchived scripts. Uh, Glad I could introduce you to that concept in the Splunk platform. So by the time we're getting here, you're sort of maybe getting the impression like, hey, there's a lot of different ways that you can extend the Splunk platform, different ways that you can inject logic. That is correct. And so my intent with this talk as I continue is to just sort of spark your imagination with different things you might not be aware of that you can actually do as you're trying to deliver these business outcomes to your customers. So search. I'm going to start by introducing both, and then I'll go into the less common one first. So there are two different main ways that you can extend SPL. I want to make clear from the beginning, I'm talking about SPL1 at this point in time, so that uh, we don't get confused with SPL2. SPL2 has some similarly named features that are much closer to what you expect of a macro in SPL1. So again, specifically, I'm talking about SPL1 at this point in time. Cool. So the two main types of search extension are external lookups and custom search commands. And there's a quick example of what those look like on the SPL line here. So you're injecting a new type of command that the SPL processor and the search bar will actually recognize as valid, provide help text for, all that great stuff. The key difference to be aware of is external lookups are super, super fast. They can distribute to the indexer tier. The SPL processor can optimize around them, all of that good stuff. Asterisk if you are using them specifically for lookup matching. If you are not using them for lookup matching or trying to do something a little bit more interesting, don't do that. Use a custom search command instead. Custom search commands are much more flexible. They're a little bit more complicated to use, but certain types of extension of custom search commands can distribute to the indexer tier. The SPL optimizer can work around them. That's where a lot of the complexity comes in the first place. And your range of use cases is going to be much more flexible, much larger for custom search commands. So if you have some sort of lookup matching, do not try to use a custom search command for it, I guess, is the big takeaway from this. So external lookups. Why would you not just use the built-in Splunk CSV lookup format? So, okay, there's a lot of cases where you actually don't want to use that sort of CSV handling or KV store handling for a lookup, including when there might be some special processing that you would need to do in order to be able to do a match, including in cases where your lookup is not stored within Splunk, either because it is massive and trying to import and synchronize the entire thing is kind of a non-starter for your customer, or because that external lookup might be changing on a regular basis. So if it's a small lookup that you can import into Splunk and you're sure you can keep it synchronized, obviously use the out-of-the-box functionality. But if it's not one of those things, external lookups might be what you're looking for. So the interface here is also very simplified. At a high level, you should think about it as Splunk is handing your script over standard in a partially filled CSV, and your script's job is to fill that CSV out and hand it back. So all you do for this is you provide a transforms.conf to register your lookup script. You provide a lookup script, which I don't know why I forgot to include on this slide. Sorry about that. And then you include a fields list, which is how the SPL optimizer is going to understand when it can use the external lookup and how to optimize around it. So what does it look like? Pretty straightforward again. There's actually not much that I'm hiding in the code example here. Like you literally are just going to go through each row that Splunk hands you, perform your match, and then hand it back. And Jeffro asked a good question, like how large of an external lookup can you use? You actually, as the app developer, make this decision. So one of the advantages here is you do not have to load that entire lookup into Splunk. You can integrate with an external database or an external API to do that lookup matching, specifically so that you do not have to load the entire lookup at the same time, right? So gigantic external lookups is one of the real use cases here. So the implementation is pretty simple, right? Uh, yeah, that's basically it. So let's talk about something that's not pretty simple. So custom search commands are substantially more complicated. Um, Note that there are two protocol types for custom search commands, and I'm just going to knock one out for you right now. Do not use the V1 custom search command protocol. You may see this listed as intersplunk in some documentation. So for every chunk of data that Splunk hands your custom search commands script handler, the V1 custom search command protocol starts a new process. So anywhere that process creation is expensive, so Windows or large data sets, uh, V1 custom search commands will always lose out. Use the V2 custom search command instead. Past that, they may look superficially similar, like both of them can distribute to the indexer tier for parallel processing, stuff like that. But the way that process management is done with V1 custom search commands is inferior. Do not use those. Cool. With that decided, there are 4 types of custom search commands that you can implement, and understanding what those mean is kind of important for you to select which one makes the most sense for the new search command that you're going to introduce into Splunk. Most of what you're probably going to deal with are things like streaming search commands. So that's where you have an action that you're going to take on every single event in the data set in isolation. So the other data sets, the other events don't matter. The aggregate of the other events doesn't matter. There's nothing that you're trying to calculate across events. That's very fast, streams very well, and is a really excellent target for custom processing that you would like to probably like to introduce with a custom search command. You may also see generating commands in some specific use cases. So a very specific example that you might find in illuminating for this is if you want to bring data into Splunk to assist in part of your processing, but you do not want to ingest that data for some reason, you can use a generating command to essentially create these new events as far as Splunk is concerned, pull them in from a different system or whatever, um, and Splunk will not index those, but it will use them in the rest of the SPL pipeline. So this is very, very massively useful when you're just trying to pull in data for the purpose of processing other events, not because you want to maintain that data in Splunk for whatever reason. Eventing commands are those where you are going, oh, and sorry, I should say, generating commands cannot distribute to the indexer tier. They must run on the search head. So this is where you need to really be aware, like parallel processing will not do you anything here. So if creating those new events is going to be like a process intensive process, you may want to consider indexing them instead through a mod input or whatever. Eventing commands also cannot distribute. These are ones that you would use to like filter the complete data set based on thresholds or something like that. Dynamic thresholds. And then reporting commands are used to summarize results. So if you're familiar with the underlying implementation of how Splunk does searches, there's a map phase, reduce phase. For reporting commands, the map phase is what distributes to the indexer tier and can be done with parallel processing. And the reduce phase does not. That requires pulling the events back to the search head. So there's a little bit more complexity with this. But that's because of the precision in which you would be introducing this new command into SPL. Cool. So what are the key components? You have a commands.conf, which is essentially registering your new search command with Splunk. And then skipping down to the bottom, you have a searchbnf.conf. Why am I listing that as the second thing? If you want people to be able to use your custom search command, you will need to provide examples and help text. You'll need to be able to specify what the fields going into this SPL command actually mean. Searchbnf.conf is how you actually communicate those back to the person who's using your command in the SPL search bar. So really, really important, in my opinion, to making sure that people can actually use it. The protocol selector for V2 is chunked equals true. You must specify that as you're implementing a custom search command. And then the last thing I would say is I've sort of been saying like, hey, the script for this isn't complicated. Here's the script that you would need to implement. The script that you would need to implement is complicated for custom search commands. So I would not recommend trying to do this yourself. I would recommend using the version that is included in the Splunk SDK for Python and subclassing one of those search commands as your starting point. Okay, so what does this look like? Commands.conf, I wasn't kidding. That's really all there is to it. And then in your searchbnf.conf, this is what I was talking about with examples. So you have a comment, an example, and you just are putting in an integer on each of those. And then this is what Splunk will display on the search bar when somebody types in just my command in the search bar. They'll see all of these help texts come up. Then what does the implementation look like? There is a lot hidden in these comments, and there is a lot hidden in the streaming command class that we are implementing here. There are thousands of lines of code in the streaming class. So again, I'm not going to sugarcoat it for you. These are very, very powerful, but you need to understand how they're implemented, and it will take some time for you to get it right. So I would highly recommend you start from one of the examples that we've published in our GitHub repo. I'll link that at the end of this talk. But the overall structure of this script is not too bad. Basically, you are just defining stream for streaming command and some other default methods for the other type of commands. And you're just performing some action on each event that is streamed to your command and then returning a new version of that event as part of your output of your command. And that's it. Minus all the stuff I'm not going to talk about. But check it out in the Splunk SDK for Python. Okay, search, that's pretty much all there is to it. But now you may be thinking like, oh man, I've got all these searches in my app and they do something that's really valuable, but then I need to trigger some sort of action in order to have a full end-to-end valuable workflow. Let's talk about it. There's two main types of ways that you can provide this sort of functionality in your app. The first is called a modular alert. So essentially what this is you have a saved search that runs, that you define and runs on a schedule or whatever. And at the end of that saved search, you want to take a action on any of the results that are returned. So out of the box, Splunk ships some alert actions like email. So you can like email someone a summary of the search results that come in. But that's an extensible part of the platform. You can do any sort of action at that specific point in time. Splunk is just providing us a hook at the end of scheduled search execution for you to tie into. So if you wanted to send your results to another system, like you have a security result that has been returned by your search and you need to send that data over to your security enforcement system, that's how you would actually take this on a scripted, scheduled sort of uh, timer-based trigger. So what are we actually going to do? We're going to include an alertactions.conf that defines your modular input, again, registers it with Splunk, along with any parameters that it would need in order to actually function. So parameters are going to get kind of important with alertactions.conf. It's a lot more than what you would expect for a modular input, a lot more important than what you would expect for a modular input because you expect to have potentially a lot of these alerts being used on your system. So because the configuration is important and admins are going to have to do this a couple of times in all likelihood as they use your app, we have included a configuration interface. And there is an error on this slide. We'll see if anyone catches that. You include a configuration interface for your modular alert that allows you to add help text, allows you to add validation when people are going through that configuration process. And then at the end, you just have a script that matches your stanza name that provides the implementation for this. Local data UI views, good guess. Any other guesses before I move on? All right, I'll spoil it for everyone. It's alertname.html, not alertname.conf. Good guess, Atul. I like that. So here's what a definition might look like. Here is alertactions.conf. Notice there's some blank fields, which are essentially specifying like this is an expected part of the definition of a modular alert, but we don't know this until it has been configured by an actual admin. And then we have our script. Notice the way this works is that Splunk is not handing your custom alert, your modular alert an event stream like you get with a custom search command, like we were discussing before, or an external lookup. It hands you the location of the search artifacts on disk. And so the way the script works is it opens up that search artifact and then takes some action on those events, right? But other than that, it really is this simple. You wouldn't need much more than this to get a full working example of a modular alert in your Python code. Here's what the configuration UI class would look like. And again, note here you can specify for the parameters that you're collecting from the admin, you can specify the type of data that they should be sending you, like is it text, numeric, whatever, and some help text to help them fill this out. So this pops up in Splunk like a modular input configuration screen so that you can, yeah, that's it. So that you can actually do the configuration for this, so that your admins can do the configuration for the specific instance of the alert that they're configuring. And then the last thing I'll say is I mentioned at the beginning of this talk that modular alerts had kind of a different instantiation format. So when you're actually looking at a configured alert, it's tacked on to the end of a saved search. So you'll see this is saying like, hey, there's a custom alert action that should be enabled. And then here are the parameters that should be passed in so they can execute correctly. Two notes. This is really easy to confuse with a deprecated feature called scripted alerts. So if you have a saved search on your stack that's configured using action.script.file name, it specifies the file right there. That's the old format. Do not do that. Similarly, if you create a modular alert, do not name that modular alert script. That will have unintended consequences that I do not want to go into, but just avoid that as you're defining your modular alerts. And you should be fine. Like again, this is very straightforward and has a huge amount of value. So that's if you want to take some sort of action every time a search returns a specific result. But what if you you as an admin of a stack are looking at some events that are returned in your app context and you're like, what am I even looking at? Like, do I need to send this over to another app in Splunk? Do I need to send it to an external system for processing? Like, how do I connect the workflow that my app has allowed an admin to do? So, like looking at events and trying to determine what action to take, and then actually taking that action. So, this is the only extension point I'll talk about today that does not involve code. It is a custom workflow action. And that is by workflow action, we literally just mean that right click contextual menu that pops up when you right click on a search result. So, super flexible way for you to pivot to other systems or other contexts within Splunk. So, great example. Please do not do this in your production environments. But if you've ever wondered, like for a specific field that you're seeing in your data, like what am I even looking at? Like, is this a common thing that other people have seen? Is this a standard data format that I should know about? Like, okay, you can imagine a custom workflow action that pops the field you're curious about over to a search engine of your choice that allows you to get more information on that right from this context. All right, it's a little more complicated than that. Because there's no script with custom workflow actions, there's a lot more configuration that you should be aware of. So in workflowactions.conf, you will have a stanza naming your custom workflow action, which is registering it with Splunk. You will also have an event types parameter that you must fill in. This is allowing you to specify like, hey, this workflow action should only pop up in the context menu for a specific type of events. The search engine example, you might imagine this is star. But if you're trying to do like IP lookups, like if you're trying to send this to a system that will see if there's a geolocation associated with a specific IP address that you're curious about, then you might want to specify this event type. The only valid event type for this workflow action is IP type of data. Cool. There's also two main flows that workflow actions can take. You either have search, and that is saying, I would like you to pivot to this other app context and then run this search in the context of that app. So if you need to pivot to a different app on your same Splunk deployment to continue the investigation, then search is the type of custom workflow action that you would want. Otherwise, if you're trying to either do a get or post on an external URL, you'd use the type equals link parameter. So this is allowing you to say like, hey, open a new window. Here are the arguments I want you to run. Here, and then just like take the user literally to that information. So when you are constructing these URLs, you can of course use wildcarding for the field name for the source data, field value for the source data, so that you can construct that URL and then send that information to that other system. So I mentioned one example use case of this might be IP lookup. You can also do things like say, like, hey, I have determined that the following username is taking some sort of malicious action. Let me send that username over to my security system to have them suspend that account, right? So it really is supporting the workflow that makes your app have a seamless way of delivering that specific business flow to the end users. So what does it look like? Back on the search engine example, pretty straightforward, right? So you're constructing that URI that you want to redirect people to on that custom workflow action, and then constructing that with the wildcarded value that you're getting from your search results. I'm a huge fan of these. Like, they're very straightforward, but they provide a huge amount of value for workflows and make your app much simpler to use. So definitely check them out. We have 15 minutes left. Okay. We're going to glaze over this topic because I want to, well, two reasons. I want to get to the debug discussion, but the API has a lot of really good examples for how to build custom REST endpoints already. So I'll take some time to disambiguate between the different types of custom REST endpoints that you may see. And then we'll dive into a couple of examples, but a lot of this is really well documented. So fundamentally, when you are building a custom REST endpoint, you need to consider, is this part of the Splunk web platform, like I was saying at the beginning of the talk, or is it part of the Splunk core platform? If it is part of the Splunk core platform, do I want it to still be accessible through the Splunk web REST API? Okay. If it is part of the Splunk core platform, is it just a generic REST API endpoint where I want to provide some custom handling? Or am I trying to extend Splunk's configuration interface for my app zone custom configurations? So those are the key choices. Let me make the first one easy for you. So Splunk web custom REST endpoints are deprecated. We are working on removing them from the platform. There's been some communication going out to app developers for a couple of years now. Um, this is not a good development pattern to inject custom REST endpoints into the Splunk web platform. So if you have one where in Splunk's web.conf configuration file, you're just doing an endpoint sort of stanza and defining your own custom REST endpoint right there, do not do that. I'm happy to work with you one-on-one to migrate you off of that pattern, but this will be going away in the future. Cool. So Splunk core platform, essentially you can use this whenever you're trying to expose bespoke logic for your app. And the one I will always talk about as a key use case here is if you're trying to handle update logic in your app. So when you update your app, if there are functional changes to configuration, or you need to move from one format of configuration to a different format of configuration, um, this is a really slam dunk use case for a custom REST endpoint. You can combine this with app.conf's trigger feature, which allows you to say, like, anytime there is a state change to my app, please call this endpoint, and it will help navigate that update. But also, it's kind of a wildcard feature, right? You can use this for basically anything you can imagine, from license validation through custom processing through configuration management. So custom REST endpoints are very, very widely used across all the apps in our fleet, and you definitely will become familiar with them. So the other main decision you have is around persistence. So if you expect your custom REST endpoint to get called frequently, you might want to consider a persistent custom REST endpoint. What that means is Splunk will invoke your script, but then leave it running for 60 seconds. Every time a new request comes in, it refreshes that 60-second timer. So if you're expecting to handle like a lot of requests all at the same time, then a persistent custom REST endpoint is probably the right route for you. Otherwise, a non-persistent request where you need to make sure you're dumping state between each invocation or something like that, that would be a use case for a non-persistent custom REST endpoint. And there are some consequences to that decision. We'll get into that in a second. So I mentioned the configuration interface. That is the extensible admin interface type of custom REST endpoint. What you do to actually implement that is you subclass Splunk's mconfig handler interface. So notice where this is defined. You're literally pulling in this class that ships with Splunk Core as your definition of what a REST API endpoint must handle. And so this can change between Splunk releases in a way that the custom search commands that I showed earlier cannot, or the or external lookups cannot. So custom search commands, your interface is coming from the Splunk SDK for Python, and so it changes when you update the Splunk SDK for Python. Um, the uh, the handler the handler prototype you're implementing for custom REST endpoints comes from Splunk itself, and so it changes any time your customer updates the Splunk deployment where they are running your app that has custom REST endpoints. So pretty key difference there, right? If your app includes custom REST endpoints, what this means is you really need to pay attention to Splunk releases and test your app thoroughly, because if this class changes, then your endpoint may start behaving differently. Okay. So that's just a general note on these. I would note that with extensible admin interface endpoints, Splunk's auth system comes for free, and the whole point of this type of extension is to make it easy for your app's custom configurations to look like Splunk default configurations. Um, so the way that this interface is exposed, it makes it look like you're working with any other conf file, which is good. And this is what you'd end up with a persistent extensible admin interface class looking like. You have a couple of methods you need to implement for the actual handling of this, but the template makes it pretty straightforward what you're supposed to do. Yeah, sorry, I should have said at the beginning, aloha kakao. It is around 11 a.m. here in Maui, and the birds are going crazy for some reason. Sorry about that. And then your configuration looks a little bit like this. Note there's kind of a split definition here. You have the exposure of the basic handler, which is just registering the extension point with Splunk. But then in web.conf, if you choose to expose your handler through Splunk Web as well, you have to re-register the routes that should be sent to this custom REST endpoint. So I said I'd be fast, and I'm not being very fast. Just to get through this a little bit faster, here is what a non configuration interface endpoint looks like. So the difference here is you're inheriting from a different prototype class within Splunk, but it's a little bit more streamlined. Like Splunk is just going to call your handler here and then pass that information along. Um, so there's not as much of like the existing interface for configurations that you're trying to align with. It's just an endpoint that will get called and then move on. So this is what it looks like. Just getting sent data in, just handing a response value back. Okay, but let's say that maybe what I was talking about with the importing this interface from within Splunk is not for you. You can choose violence here. You can just pick a different type of custom REST endpoint that does not use a default handler from Splunk at all as its starting point. The main difference here is a little bit subtle. It's you just have script type equals Python in your restmap.conf definition of your custom REST endpoint. And this tells Splunk like, hey, I'm just going to fire a request to this. It will handle it. I don't have any expectations around the formatting. So to be clear, when you choose not to use these interfaces, you do have to consider authentication, input validation, all of that stuff. But this is the most flexible way you can expose a REST API endpoint through Splunk. Everything else works the same as one of the others. It's just you are skipping all of the default handlers and just providing whatever functionality is necessary here. We're going to do it. We're going to get through debug because this is the coolest extension point. I mentioned earlier that the Splunk CLI was extensible. This is what I was talking about. So the Splunk CLI exposes a diag command, and you can handle requests into that command through your app. So diag is essentially a debugging tool that support will ask customers to run when something is going wrong and they don't understand why, and they need more context in order to understand what's going on. So the cool thing here is diag does not expect Splunk to be running. Diag expects that Splunk is actually not running and that it is completely non-functional when diag is run. And so there's no dependence on Splunk being running or in a runnable state when you actually use this. So Your script is executing fully independent of the expectation that your app works. And your goal is, how do I help someone understand why that is? Is it my app's fault? My app isn't running, so I can't ask it if it's working, right? But I need to provide some sort of context that can either help someone understand that my app is broken or understand why my app is broken. So this is going to be very highly dependent on your app. Like, you might want to check for like required configuration missing. You might want to check if the integrity of the app package is intact. Did it get deployed incorrectly? Is it missing a license key? Did somebody go in and just remove a bunch of the handlers? Like, all of these are things that you might want to consider. Is there an internal log file that might make sense to return? Like, all of that good stuff. You can also just return a script saying, for any issues with this app, please contact developer name. Like, I would accept that as well, right? But this is kind of up to you. So here's how it works. And that's it. So you are specifying in app.conf that you have a specific diag extension that should be run, and then diag will call your app, hand it an object, and then you can append additional information to that object. That's it. It's very straightforward, but super, super useful. So we discussed a whole bunch of the platform. What I didn't discuss are things like extensible portions of the admin interface, like you can extend the credentials policy of Splunk with a script. You can extend authentication to external systems with a script. I didn't discuss custom visualizations. Those will be discussed a little bit later on. I think all told, I might have covered about a third of the actual extension platform, but I'm deeply passionate about this. So if you're curious about anything else, please hit me up on Slack. I have so much to say about our entire extension platform and want to make sure that you're able to, again, deliver business outcomes to your customers. The main resources, if you haven't seen them before, are the following. But if you get on that Slack workspace, you can always reach out to me and I can point you towards the best stuff. Cool. That's it. Let me check if there are any other questions real quick, and otherwise I will hand it off, Renita, to you. Okay. Yeah, Kyle, custom diag scripts are not super common. I think I've seen about 50 of them in 10 years. And I definitely know that you know how they work. So I appreciate you there. But I'd like to see more of them because of how important they are. Oh, Jeffro, good to see you. Health style endpoint. Yeah, so Splunk has a checklist.conf, and you can essentially say, like, here is some SPL. And if this SPL returns, you have a structured format for that. If it returns anything that indicates that my app is unhealthy, then please raise this as a warning in the monitoring console or just the monitoring console, actually. So if you have a Splunk enterprise customer who's running your app, essentially what that means is they would get an exclamation point in the bulletin board system. Man, I should have talked about that one. That's a good extension point, actually. They get a little exclamation point there that takes them to the monitoring console, and then you can literally explain right there in the Splunk standard interface why your app is unhealthy. So super powerful feature. But if you assume that endpoints are running, that basically means that Splunk is running, right? And so then you can use just a standard search in order to run that through checklist.conf. Multi-alert action. Neat. If you can file that as an idea on the Splunk ideas portal, Stephen, I would appreciate that. But yeah, if you're talking about like firing multiple alerts at the same time, that would be really cool. Persistent versus non-persistent endpoints. Yeah, Mike, we can, although I think we probably need to do that in a different thread. Yeah, I think I got most of the props.conf. Yeah, let's take that somewhere else. Oh, thanks, Stephen. I'll take a look at that. Cool. Good questions. Thanks, everyone, for keeping up with me. Sorry that was fast and I only got through a third of the platform, but hopefully that was useful to everyone.
Awesome. Thank you so much, Ted. And we are right on time. As a reminder, all of the slides and recordings will be shared afterwards everywhere that you can think of. So please don't worry about that. And if there are any questions that go unanswered, I will look through the chat and make sure they get answered over Slack. Thank you, everyone, for joining. And I will see you in the next session.